Okay, so our next dry lab or a virtual lab 3 is inorganic nomenclature. So today we'll learn how to write down the name of the chemical compound and write down the formula of it. So for predicting the formulas for inorganic compound, we have to know the cations and anions. So cations are the ions with a positive charge, for example, sodium ion, okay, Na plus, and then anions are the ions with a negative charge, for example, Cl minus. All right. So the chemical formula of the compound has neutral charge on it. That means when there is the formation of a compound, or we may say when sodium combines with this chloride ion and forms like NaCl, this charge, this positive charge and this negative charge will cancel out each other. So in the final product there will be no charge at all. Okay, that is why it says the compound is neutral. Okay, in a chemical compound the charge should be balanced, so the number of the positive charge will be equal to the number of negative charge. Okay, so let's learn how to write down the chemical formula. Okay, here the example is given for the calcium chloride. Okay, and balancing the charge using the crisscross method. So the calcium Ca, which is positive ion, all right, so Ca2 plus, which is going to combine with the Cl minus over here. Okay, to write the formula we always should write the positive one at first, that means the calcium, and followed by the negative, okay, which is Cl in case of this one. The next step is to crisscross their number of charge to the subscript of the opposite element. For example, here the 2 on the calcium is written in the subscript of the chlorine, so it will become 2 over here. Similarly, there is, it is just negative 1, all right, there is a 1 charge on it. So let's bring this 1 over here, okay, to the subscript of the calcium. So it becomes CaCl2. All right. Now let's look at the charge if it is balanced. All right. So calcium has the positive charge, positive 2 charge, and there is only one calcium, so 2 times 1 equals 2, which is positive 2 for the calcium. And for the chlorine the charge is negative 1, and there are 2 chlorines, so times 2 equals negative 2. Okay, so there is the balance of charge, plus 2 charge equals the minus 2 charge. Okay, however in the neutral compound the charge will be 0. Always remember this. Okay, so let's learn how to name the inorganic compounds. All right, there are two types of compounds, like ionic compounds and covalent compounds. So the ionic compounds are formed by the combination of metals with non-metals, all right, or polyatomic ions. So metals form cations and non-metals form anions. For example, sodium, it is metal, Na plus, and then non-metals, iodine. So we'll write iodide when it is written in the negative. Okay, so it is sodium iodide, NaI, NaI. Okay, all right. So the suffix IDE will be added by dropping INE at the end of the anions. For example, for iodine, the INE is dropped by ID. So the formula becomes sodium iodide. Okay, sodium iodide, not iodine, it's iodide. All right. Similarly, when sodium combines with chlorine, it forms sodium chloride. Okay. Now you see this INE is dropped by or replaced by ID. Okay. So in this way, we can write down the formulas for the inorganic compound. And let's look at for the covalent compounds. All right. So it is similar to the naming of ionic compounds. The covalent compounds are formed by the combination of nonmetals sharing their electrons. Okay, so there is a difference between ionic compounds and covalent compounds. In ionic compounds, the metals combines with nonmetals, whereas in covalent compounds, two nonmetals will combine together by sharing their electrons. Okay, valence electrons. So the electropositive element is always written first, followed by the electronegative elements. All right, that means if in the periodic table, when you look at it, the carbon comes first and then oxygen. Okay, so whenever you have to write down the formula for example, carbon monoxide, so the carbon is positive than the oxygen. Okay, so the carbon is written first and then oxygen. Okay, here is another example like carbon dioxide. So both carbon and oxygen are nonmetals. Carbon is more electropositive than oxygen. Okay, so to determine the electropositive or electronegative, you have to look at the periodic table. Again, I'm saying when you open the periodic table in your manual, you'll get to see that the electronegativity of elements increase going to the right. Okay, so when you go in the period, the electronegativity of the element increases. All right, and the electronegativity decrease going down in the column of the periodic table. All right, so when you go down, electronegativity decrease means the electropositivity increases. All right, so on the basis of that, you can figure out which element will be more electropositive than the other one. Okay, also we have to mention the prefix mono, di, and tri for 1, 2, and 3 atoms respectively. For example, in carbon dioxide, so carbon is positive, so it's written first, and then there are two oxygen in it. Okay, two oxygen. That is why it is written as dioxide. Okay. So another example is sulfur dioxide. Okay. All right. So some of the compounds will be formed by the cations having multiple charges on it. Let's look at one example for copper. So let's look at here, copper. It has copper 1 means +1 charge and +2 charge. All right, so the copper has the variable charges +1 and +2. So whenever you have to write down the formula for this kind of compound or having the multiple charges, we must write down the charge in the parenthesis in the Roman numerals. All right, so as you can see here, for copper plus, there is 1 plus, so we should write copper 1 in the parenthesis. Okay, Roman numerals in parenthesis. Let's look at one example. The name given for the compound is copper 2 nitride. What does that mean? Yes, copper 2 means the copper has 2 plus charge on it. All right, so the nitride is N minus 3. Now let's write the formula using the crisscross method. Again, you write down the positive part first, which is Cu, and then negative part, which is N. All right, now let's bring the number to the subscript of the opposite element. Okay, for example, copper has 2 plus, bring 2 the subscript of N, and nitrogen has 3, so bring this 3 in the subscript of copper. All right, but regardless of the charge. All right, just bring the numbers down. Now let's see if the charges are balanced. So copper, now you see there are 3 in this formula, times 2. Okay, this is the charge, so 3 times 2 would be like +6. Let's look at for the nitrogen. There are 2 nitrogens, and each nitrogen has -3 charge, so when you multiply this, it becomes -6. Okay, so the charges become equal and it is balanced. That is why this neutral compound, all right, means there is no charge. Also, we can write down the formulas with the polyatomic ions. For example, when you look at in these tables, you'll see lots of polyatomic ions having the charges on it. Okay, so let's look at the first polyatomic ion, which has the positive charge on it. This is known as ammonium. So the NH4 plus, this is the single unit. Okay, NH4 plus is a single unit. So whatever you see in this table, these are all the single unit. Okay, now let's try to write down the formula for ammonium nitrate. So ammonium, let's look at in this table, which is over here, has the formula NH4 plus. Okay, and for nitrate, NO3 minus, which is here, write it over here. All right, so now regardless of these charges, bring these 2 units together. So always the positive one first and the negative second. That is why the first is NH4 and the second is NO3. Okay, since it has the polyatomic ion, I'm just writing these in the parenthesis just to show you how to write it in the easier way. Okay, now let's bring the number from the each unit to the subscript of the other element. So ammonium plus 1. Okay, so bring the 1 under the subscript of nitrate, and bring 1 from the nitrate under the subscript of the ammonium. All right, but we are not going to write down the charge over there. Okay, so the number that we bring in the subscript are regardless of the charges. Now you see it becomes NH4NO3, but we'll write these as NH4NO3 for the compound. All right, we don't write the parenthesis over here. So this becomes the ammonium nitrate. All right,